Thank you everyone for joining us for this webinar presentation. We're just going to give another minute or two to allow some people to log into the webinar system, so we appreciate your patience. Okay, we're going to begin our webinar presentation on the key maintenance items for high-rate anaerobic reactors. My name is TJ Willits, and I'll be your moderator for today's webinar. I'm excited to share this information for our final webinar for 2018. So I have some housekeeping items before we get into the main presentation. Obviously, you should be hearing me now, and if you're not, there's two audio options, and you could go ahead and modify those audio options to either call in on your telephone or use your computer. Just want to remind everyone that the webinar is going to be recorded, so you could view this webinar again after the broadcast when you receive the follow-up email tomorrow. Lastly, we're going to be taking questions throughout the webinar and then addressing as many questions as possible at the end of the webinar. There's a question panel on the right-hand side of your screen. Feel free to type in your question and we'll try to get to it after the main presentation. After the webinar, you'll be directed to an online survey. Please take a few moments to fill out this survey. It really helps us custom tailor the content to the people that the content matters the most for. That's you. Also, in the survey, you'll see a place to request a participation certificate. Go ahead and click yes if you'd like a participation certificate. Also, if you're watching this webinar broadcast with multiple people in the room, there's a place in the survey for you to type their names so we can make sure that they get a certificate as well. Without further ado, I'm going to introduce our speakers for today's webinar. Our first speaker is Greg Rosenberger. He's the Technical Director for Veolia's process team. He has over 20 years experience in wastewater treatment in a broad range of industrial clients. Also joining us live from a client on site is Jill Jordan. She has over 35 experience in anaerobic treatment for a variety of reactors such as UASB, EGSB, and CSTRs, and she'll be joining us here in a moment as well. Without further ado, I'm going to hand the webinar broadcast to our first speaker, Mr. Greg Rosenberger. Greg.
Hello, and thank you, TJ. So for today's webinar, as TJ mentioned, there's our fourth webinar in the series, the last one for 2018. And for the first few slides, we're just going to quickly review what we did on the first three webinars for those that were on it, a little bit of review for those who were not on the earlier webinars, some things that you might have missed. You can, as TJ said, these are all recorded, so you could go back and listen to them if you would like and view them. But our first webinar, we just sort of went over the basics of the biology and chemistry of an anaerobic digestion system. Looking at anaerobic digestion involves many different types of bacteria all working in harmony together. Primary species being the acid-forming and methane-forming bacteria. The methane former or methanogens are the slow-growing, the more sensitive bacteria. Those are the ones that we like to keep happy in the system in order for the anaerobic reactors to work well. The acid formers are the ones that produce the VFA for the VFA testing that you do. And we looked at some of the key things to keep anaerobic treatment and the anaerobic bacteria in good condition, those being controlling the amount of food or COD that you feed to the system, the pH of the system, typically around a neutral 7, the temperature of the system. Anaerobic systems run in a mesophilic mode of about 95 Fahrenheit, 35 Celsius, and making sure that we have the proper nutrients, both macro as in nitrogen and phosphorus, and the micronutrient solutions, and finally keeping away inhibitors such as quaternary ammonia or other biocides from entering the system. Our second review is we looked a little bit about the operation efficiency of the system. We went over the different types of anaerobic reactors, the high rate reactors, lagoons, CSTRs, recognizing that all of them have a lot in common and that they had the same bacteria in them. So a lot of the things are equal between them when it comes to looking at operation of a system and how they run well or do not run well. We went over a lot of the different testing that you should be doing on a daily basis, on a weekly basis, both lab and field testing. Those key tests being VFA testing, COD, suspended solids testing, and making sure that you keep your pH and temperature and nutrient testing, both from field instrumentation and lab testing. And finally, in our third webinar, we tried to look at some of the things that cause upsets and how to prevent them. A lot of it being keeping up with your system maintenance, keeping up with calibration of pH probes, looking at temperature transmitters, etc. Keeping things, if you have a SCADA system and you have automatic control, trying to keep as much as possible in auto and not putting things in manual. A lot of issues coming when things go into manual and they don't get put back. Don't ignore alarms. A lot of times there are a lot of nuisance alarms, but you need to take a look to make sure that everything is there. An alarm means something isn't working, whether it be the instrument or actually something in the system. And we talked about doing the testing requirements on a daily or weekly basis to make sure to monitor your system and have some historical data to look back on. So today, we're going to go over a couple different items. One, safety. There's a lot of safety aspects around anaerobic digestion. Specific maintenance items for our high rate anaerobic reactor operators out there. There's a lot of unique things there that we're going to go over. We're going to look at the feed piping. We're going to look at the settlers. And then we're going to finish off with the general biogas handling equipment maintenance procedures, which are relevant, obviously, for all anaerobic reactors. So, as I always like to start out with safety. When you're working on an anaerobic system, you do have to take safety into account. It is very important. There are a lot of different safety issues around anaerobic systems. Obviously, in a lot of anaerobic systems, if you ever do go in, they are confined spaces. There's tanks. There's specific confined space entry procedures that you really have to follow, especially if you're doing some downtime and you take your reactor down or you take a wastewater holding tank down, you have noxious gases in there. So it's extremely important to make sure that you follow the proper confined space entry procedures on any shutdown that you take. The second thing, and obviously I think the most obvious but also the most dangerous, is anaerobic systems make biogas, and biogas is dilute methane gas and it's toxic. No smoking, no lighting torches, no welding, etc. No open flame should be near an anaerobic reactor. Remember, this is not just the anaerobic reactor at the top of the reactor itself where the PRVs are. If you have some wind and you have a weeping PRV, that wind can blow that biogas down to ground level. So you have to be very careful around biogas. And also looking at biogas, you're not only talking about the reactor itself, you're talking about biogas pipelines. We do have flanges on biogas pipelines over time. Maybe the gaskets start to get old, they leak a little bit, so you can have gas there. You should always carry your H2S and your LEL safety detectors. If you don't have them, you can talk with Jill Jordan after the webinar to look. We recommend that all operators, while on site, carry this. It can clip on to your belt. It will detect methane. It will detect H2S. But safety is very important, and it's not just little safety things. These are big issues here. You always read once a year about an operator in a wastewater treatment plant where there is a fatality due to breathing in too much H2S, an explosion, going into a confined space. So it is important to keep in mind. As we look into the high-rate reactor systems, we're going to go over some of the key maintenance procedures and maintenance things you should be doing. Many of those focused around the two main components of an anaerobic system and a high-rate system. Those are the settlers and the feed distribution piping. So the settlers, what are they? Sometimes they're called settlers, sometimes they're called three-phase separators. They separate the biomass solids from the effluent from the biogas. If you see your little animation going on, the yellow is the biogas, the black is the anaerobic biomass. It hits the underside of that settler or three-phase separator and it degasses. And the biomass falls back down into the bottom of the tank. It settles. The gas goes out around to the top of the reactor, and the clean effluent overflows some submerged pipes. Some of you people might out there have older systems that have weirs in them as opposed to exposed pipes. And then you have the biogas, which essentially goes out in a biogas channel up to the top of the reactor, and then it is vented out to the biogas system and the flare. So that's just a quick little overview of how a three-phase separator works if none of you have ever seen them inside in that animation before. So for the open-top reactor people out there, a lot of people out there that have UASBs, a couple of the high-rate biobed systems do have open tops. You should be doing some routine maintenance on those settlers. You can take off the cover panels. Be careful when you take off the cover panels. Safety issues, have your H2S detectors. Don't stick your face right down in it. You get overwhelmed with a puff of gas a lot of time because they are gasketed down there. When you take the covers off, you should see some effluent collection troughs and some weirs. You should evaluate those weirs, make sure they're level. Obviously, you can tell if they're level or not by just looking at where the water is overflowing or not overflowing. If it's all overflowing in one area, that means you're going to have a hydraulic rush through that area. You won't get as good of clarification, and the weirs should remain clean. You might have to go up there with the hose and clean them, or just take some type of broom or something and sweep them off a little bit. But if you have a whole lot of debris that is up there, they should be cleaned on a somewhat frequent basis, depending on how well they dirty or don't dirty. So you should level the toppers. You should clean and level the toppers. We recommend at least twice a year. It might be more, it might be less, just really depending on your system itself, but they should be inspected like on a monthly basis. You should be up there and taking a look, taking a cover two off and seeing how things look, maybe even take a picture or two. Every reactor is a little bit different depending on the wastewater that's being treated. Some systems can sit there for years and years and years upon end and be fine. Some systems get jammed up with debris more often. Depends a lot on your screening influence and just how dirty your water is. You might have some sulfur buildup, some white crusty material that's a lot of times calcium sulfate can build up in some of those things that are a little bit more difficult to get off. So that might have to be something that you have to figure out a little bit of a different way to get it. But the key is that you should be inspecting them and doing some routine maintenance cleaning of those on some type of periodic basis, depending on your system. For closed-top reactor systems, people out there have some biobeds that you cannot have access to the settlers and weirs. There's not a tremendous amount you can do there. They aren't as susceptible to build up because you don't have any air in that environment. A lot of times some of the issues that you see is due to the air creeping in an open-top system and creating some reactions or creating some issues with sulfur. So for a closed-top system, there's not a huge amount that you can actually do there other than some systems. If you go to the next slide. Some systems do have some viewports in them that you can try to take a look at just to see if you see some issues with settlers in a closed-top system. If you think you're having settler issues, the only thing to do then would be to take the system down and do a pop the top manway and go in. So that's a little bit more difficult. Obviously, you're going to need some downtime there. There are sometimes you can do a little bit with the influent feed piping by trying to increase some flow through it for a short period of time to wash things out. There's a couple small things that can be done, but closed-top reactors are pretty much just manually try to take a look at it, and if worse comes to worst, during a planned outage, prepare to do a inspection of the internals. Remember, when you're looking at a closed-top system, that is a gas space in there that if you do go down and do an inspection, you have to purge that space. Typically, you purge it with nitrogen gas before opening it, and then when you do opening it, you have to treat that as a confined space because obviously you probably have a little bit of gas that will be weeping into the system when you go down. You should try to make sure you have your LEL detectors up there and your oxygen sensors. So if you're going to take your closed-top system down and you're going to draw the water level down a little bit and actually go and do an inspection, please give us a call. We have some procedures that we can help work with you. We can send a technician out to the site to help you do that inspection to know what you're looking at. It's not something to be taken lightly. It does take some time, so you're going to need some downtime, and there's some safety issues you have to take into account before you do this. So now I'm going to turn it over to Jill, and she's going to go over the feed distribution piping and what to do there, as well as look at the biogas system maintenance that you should be doing. So Jill, it's up to you here.
Thanks, Greg. Thanks, TJ, and thanks everybody for being on today. Glad you're all back. We're going to talk about the feed distribution piping in these high-rate systems. Every plant, whether it's ours or somebody else's, has a feed distribution piping system. And the idea is that you want to get the water into contact with as much of the biomass as possible over the floor of the reactor so that it filters up through the sludge bed. But all these piping systems have nozzles on them, and they can be susceptible to clogging. And if they do get clogged, the area that's clogged doesn't get any food, and then the area that's not clogged gets overfed, and that can cause some system performance issues. So the idea is, how do we keep them clean and keep them working? Next. So the first way that we can help to keep this feed distribution piping clean is to prevent solids from getting into them that would clog them in the first place. So most of our systems, as most people notice, have some sort of screening up front to keep things like bottle caps, coffee stirrers. I don't know why, but we always have a lot of coffee stirrers. Anything. This particular picture is of at a brewery, and there's grain. You want to keep grain out of there. Any big thing that could clog a nozzle, because most of these nozzles are maybe 3/8 of an inch to 1.5 inches in diameter. So you want to keep anything out of there that could clog those nozzles. And one of the ways that we can keep it out, besides the upfront screening, is to hydraulically purge the piping, and we can also use high-pressure cleaning to clean out the system. The high-pressure cleaning is not easy to do, but it can be done without taking the reactor down, which is always something nice. Nobody wants to take a reactor down to clean this piping out. What we have to do is put a T at the front end of the header going into the reactor. On this picture to your right, the digester tank is on the right, and the feed's coming in that top pipe and going down. And you see that there's at least 3 valves on there that we can operate, and a blank flange, or a blank flange that's usually on that back end where it says remove existing blind flange. What we do is we take that blind flange off, not while it's running. You have to close the butterfly valve up front of that one header. All the other headers can be running at this point, so you're only cutting off like one part of the reactor. Close the valve where it says digester feed header, which is a plug valve. You want to close that, and then at that point take the blank flange off. Replace the blank flange off with a flange that you've fitted with like a double O-ring system into it, and then you feed a high-pressure nozzle assembly or a hose through those O-ring fittings, put the nozzle on the inside, and then obviously put the flange back on, open that plug valve, and put your high-pressure washer. Most of them you can have a type of nozzle that'll force its way through into the feed piping. So that's the first way. The other way, again, not so easy, but a little easier than the high pressure washer, is to put, instead of the O-ring flange on, put a flange on that can be adapted to handle like an 1.5-inch fire hose. So you can get high pressure, quote, high pressure, high flow water through the header. And on these headers, when you do this, some of the headers, some of you guys have a header that goes straight through the reactor and has a flange on the back end. When you do that, you can open up that back flange, attach it to some hosing, and make sure that the contents are going to go someplace where it can go, like to a drain. And again, turn the high pressure water on and just let everything flush out through the back end. Even if you have a loop system, you can open up the loop system on the other side and do the same thing. And that should wash out any solids. You have to be careful, though, that you close that back end before you turn the fire hose water off, so that you're not letting solids, any of the sludge that's around there, build up and go back into the headers. That's the bad thing. A lot of people want to suck these headers out, and that's like the wrong thing to do, because that just pulls in sludge from the outside, from the sludge bed into the piping, and that causes more plugging. We can also try to minimize the amount of plugging that happens by mixing the sludge bed. You guys may know it as fluffing the sludge bed, mixing the sludge bed, doing a header check. We have several names for it. But here, we just use your regular piping and regular pumps that are already part of your system, and we send all of the water through one nozzle at a time. And we do that by putting the reactor feed flow nozzle into manual, opening it up 100%, or if you have a VFD drive, putting it to a defined Hertz output. Then you bypass the mixing valve or open them up 100%. Bypass everything else in the line, like a heat exchanger or something like that. It could be anything else. And then open all the valves and read what the flow is. That's the all open flow. Next slide. Then close all but the first header valve, and allow all that flow to go through just one valve, one header. Record that flow. Then open the next header, close the first one, do the same, work down the line, and record each of the flows through each of the headers. Some of you may have 4 headers, some of you may have 6 headers, some of you may have 12 headers. Just depends on the size of your reactor, and you just need to record the flow through each one of them. When you're done, you want to open everything up and get your all open flow again, and then put everything back into auto and normal. You want to go through the heat exchanger, put the pulsing mixing valves back into auto, and put your reactor feed flow back into auto. Next. The nice thing about the header check mixing the sludge is that whenever we start up a facility, we do this first thing. Right after we put the sludge in, we do it before anything is clogged. So you have a background number, so you always know what the flow is when it's when you know that the headers are all clean. So that's your baseline. Then after you record these flows in the future, if you see a significant drop in the flow through any header, you know that there's probably some blockage in there. And if it gets really bad, like more than 10% of the original baseline flow, you want to try and do one of these procedures we just talked about to get the flow back to normal. Next. Okay, let's talk about some biogas handling equipment. Again, as Greg already said, handling the biogas is dangerous. It can be. The biogas is flammable. It's toxic. And you need to keep the equipment in the biogas handling system in good operating condition for your safety. It's all there to control where that gas goes and how it's handled. And if it's not handled in a safe way, you could put yourself in harm's way. And we don't want that to happen to anybody. Next. When the gas comes off the top of any reactor, it's saturated with water vapor at the temperature that the reactor is running at. And that can be quite a bit of water. So one of the first things in the biogas train is usually a sediment trap. And the sediment trap's there to collect any condensate that might be come out of, and all the condensate that comes out between the reactor and the sediment trap. And it also collects foam. Every once in a while, a system will have some foam in it, and that can get carried down the gas line. You don't want that foam to go very far down the gas line because it can clog the gas line. And if you clog the gas line, you lose control of the back pressure in the reactor. All of our reactors are usually run under positive pressure, except for like our lagoons and big reactors that have a membrane top. But we want to make sure that all of that foam and gas liquid gets out of there so that we can control the pressure, whether it's negative or positive, in the system. And if we have a lot of moisture in the lines, that hinders us in doing that ability. So you want to keep it drained and clean. Drip trap. The moisture, again, that condenses in the biogas line as it cools, and each time it goes through a pressure drop, like a valve or a flame arrestor. So we provide drip traps at each of these locations and at low points in the line to collect this condensation so that it doesn't build up in the line. And we always provide the type of drip trap that allows the condensate to form into a reservoir, and as the reservoir fills, you have to manually open the valve to let it drain out. And when you do that, you actually close the gas, you close the valve to the gas so there's no biogas coming out, which makes it a lot safer than just opening a line and draining it. So you're never exposed to the biogas with these types of valves. And when you have these, you have to make sure that they're clean, drained regularly. The more gas you make, the more frequently you have to drain them, and the colder it is, the more frequently you have to drain them. The other thing that's typical in any type of anaerobic reactor is some sort of back pressure regulating valve on the biogas line. And these are typically diaphragm type valves. So you have to make sure that the sensing lines are not clogged and that condensation and foam don't get into these valves or they don't work right. You can also have like a regular control valve, a butterfly valve or V-notch valve, whatever, on a gas line with a pressure monitor and just have a PID loop operating there. All the equipment, if you have any electrical equipment near a biogas line or within 10 feet of a biogas line, I think they have to be Class 1 Div 1. So that's a pretty hefty expense to make everything Class 1 Div 1. So these diaphragm valves are much simpler and more friendly to use in those situations. Next. All the tanks that we provide in all anaerobic reactors in general should have some sort of pressure and vacuum relief valve on top or on the gas system or on the reactor in some place. You have the pressure relief side to ensure that if the gas line gets blocked up, the gas pressure can be relieved at a point before it would be damaging to the reactor. If you build up enough pressure, you could blow the settlers out. In some instances, you can actually damage the tank, the roof of the tank. So we want to make sure that that doesn't happen. We provide pressure relief valves that are circled on the picture there. And on the and they're the ones that looks like it's a little hat. That's the pressure side. The vacuum relief is on the right side there that sort of sticks out. And we have vacuum relief because, God forbid, somebody runs into the tank and lowers the water level rapidly, or somebody breaks a line and the water level drops rapidly in the tank. You could actually pull a vacuum and actually suck in the top of the tank. So we have vacuum relief up there to prevent that from happening. Next. You have to check these pressure vacuum relief valves regularly. It's just a plate sitting on a little rim with some weights on it. And the gasket that sits on that rim is really just a paper-thin piece of Teflon, a thick piece of paper of Teflon. And if it gets crinkled or it gets brittle from sitting out for 10 years, it'll leak. And again, if you're leaking biogas somewhere, that's not a good thing. It's dangerous to you, and it can accumulate in places that you don't want it to accumulate. So you need to keep these gaskets tight. Follow the manufacturer's recommendations on how often they should be checked. That's true on the vacuum and the pressure side, because if it's leaking on the vacuum side, you can actually let air into the biogas space, which you don't want to mix air and biogas at that point. So be careful. It's not rocket science to check these. I often recommend that if you don't know what you're doing, have the manufacturer come out the first time to show you how to do it, so you do it correctly, and then take care of it. Another thing we always have, you notice on the picture before and on this picture, is we have flame arresters. This prevents gas, a flame from getting back or forward in the gas line. And they're usually before these pressure vacuum relief valves in the line, and they're also in the lines going out to the flare. It's really just a bank of aluminum plates, and it acts to cool the flame down so it doesn't go any further. You can't let foam or scum build up on these plates or they don't work. I mean, it just blocks it, so it doesn't do you any good. The flame is going to try and go to someplace else. Again, you have to check these regularly, follow the manufacturer's recommendation on these. So you want to, and again, it's really easy. You can see that there's actually a little sign on the one here on the right that says open here or something like that. You just undo that flange and pull out the bank of aluminum plates. They're very easy to pull out, and put a new bank in, and then you can clean the one you just took out, put it back in. Like I said, easy to clean. Of course, you have to isolate that flame arrestor first, and there's always a valve before the flame arrestor so that you can isolate it and do that. And that's why we have, you noticed on the past couple of pictures, you had a pair of flame arresters and pressure vacuum relief valves. So we always double up so you can work on one while the other one is being in use. Okay? Check valves. There's often a check valve in the gas line going out to the flare. You don't want air, if you have a windy day, to get back into the gas line. It's just really a flapper, most of these check valves are. And it's okay if you hear them clicking. You'll often hear them clicking a little bit because the gas isn't even going, the gas flow isn't always even, and that'll make them click a little bit. And that's okay. Again, simple operating thing, but they need to be maintained to make sure that they're clean. Flares. There's two basic types of flares that we use, open and closed type flares. And the flare is there so that the biogas that's not being used is disposed of in a safe manner. Okay? Of both types of flares, whether it's open or closed, has some way to keep them automatically lit. Some of them have a Venturi with a spark fire type that sends a ball of fire down the pilot line to light the pilot. And others just have a simple sparking mechanism at the pilot to keep it lit. In the systems that we use, the line going into the flare also has a flame check valve in it. And the flame check valve has a meltable fuse in it. So if it's like a windy day and the wind tries to push the flame back down the gas line, this fuse will melt and a spring action will actually close this valve. The important thing with this is that that happens, you have to have a replacement fuse to get the system working again. On the Varic type valves, which one is shown here, I think, they usually wrap the extra fuses onto that nut on the top there. You see the round valve there with a wing nut on it. Make sure you always have them, keep them there, or put them someplace where you know where they are just in case you need one. Next. Open flares. You can visually see the flame burning. What's the difference between an open and a closed flare? On an open flare, you can visibly see the flare burning. Most of them have a Venturi type mixed pilot gas system, and a thermocouple in the pilot which determines whether the flare is lit or not. If the pilot's not lit, it's assumed that the flare is out, and if the flare is out in these type of systems, the system will automatically try and relight itself. And that's a good thing, especially if you live in a windy area that might blow, where they might blow out. Okay. The closed flares are really similar, except you can't see the flame. It's inside of a column, a bigger column, so you can't see the flame. And it's often used in places. You can see the one picture here. It's in a downtown area. So people don't want to see the flare. They think the building's on fire. And it's also in places, and enclosed flares are also used in facilities where you have a gas discharge regulation. Like you can only burn so many pounds of sulfur a day, and you have to burn your gas at a given temperature. You can control the temperature of the burn in most of these closed flares, and that makes them cleaner. So some of the states that have a lot of clean air regulations usually require an enclosed flare so that they can regulate the temperature. And if you have the temperature control, it's usually done with louvers, so you have to make sure that the louvers are always maintained and free moving. Let's get off of biogas and talk about general maintenance of equipment. To make all of these systems work well, we have inline instrumentation and control programs that work to help the bacteria live well. Instrumentation can fail and go out of calibration, so you have to learn to verify parameters and calibrate instrumentation as required. And this is especially true with pH. As you know, in the past 3 webinars, we're always harping on pH, of how important it is, because it's also the instrument that can go bad the fastest. So set up procedures to do preventative maintenance on all your equipment, whether it's a pump, whether it's a pH meter, whether it's a valve. Make sure that you do your preventative maintenance on these items, so you don't run into somebody calling you at midnight on Saturday night to come in because something's failed. That's the most important thing. Next. Oh, we're done. Woohoo! So the next webinar is going to be on March of 2019, and I'm going to turn things back to TJ. Thanks, TJ.
Great. Thank you so much, Greg and Jill, for sharing all your knowledge with us about maintenance. At this time, we're going to take some questions here. If you would like, there's a question panel on the right side of your screen. Please take a few moments to drop your questions in there, and we'll try to get to as many of those as possible. While we're waiting for some questions to come in, just want to remind everyone that there will be a survey after the webinar. Please take a couple seconds to fill out that survey. Also, you could request your participation certificate for continuing education credits if you wish as well. So we appreciate you giving us that feedback, and also to help shape the content for our 2019 webinar series. Okay, I have a question here, and it has to do with flame arrestor banks. There was a question to see how many flame arrestor bank sets should there be on site in case, in terms of spare flame arrestor banks. Jill?
Oh, thanks, TJ. I usually recommend that they keep 1 per size of flame arrestor, because the flame arrestors come in different sizes. So, and they may be different sizes at different locations in the biogas line. So let's say you had 2 8-inch flame arrestors on top of the reactor, and a 6-inch down to the flare, and another 6-inch going to the boiler. I would recommend you have 1 spare bank of 8-inch and 1 spare bank of 6-inch.
Okay. We don't have many questions coming in. We do have a question about where to find previously recorded webinars. If you want, you could send me my email. I think everyone has my email from the email invites. Go ahead and send me an email and request what webinars of the 4 that we've done, and I'll send those recordings over to you to go ahead and watch, to get caught back up on that content. So not a problem. We'll get you caught back up. Just shoot myself, TJ Willits, an email. Okay, so
TJ, one of the guys here had a question, so I'll relay that. Okay.
Okay.
One of the guys here just wanted to make sure that he understood correctly that to work on these flame arresters and pressure relief valves, that you have to isolate them first. So you do have to isolate them with the isolation valve on the reactor. So there's always the pair. So you close one side should always be closed to keep it clean. And so you would open the spare side and then close the formerly working side to maintain the flame arrestor and the pressure vacuum relief valve.
And just to follow up on that, when you're talking about pressure relief valves on top of a reactor, those are very important to maintain and keep clean. We've had several reactors over the years have overpressurization issues. And what that amounts to is essentially you have a pressure surge in the system for some reason. You have no way to relieve it. It's not like the whole top of the reactor goes kaboom and it, starts flying miles away. But what you will see happen is somewhere wherever the weak point is will essentially break. So you will have some flange somewhere, or if you have a bolted tank, you might have some near the rim angle pop, and therefore you then have leakage. So basically what you then have is a leaky roof, what you're talking about major downtime to fix. We've also had several tanks that have had their vacuum sides. Birds nest in there, leaves get in there. If that Teflon seal is not proper, you can get those to freeze. And then you have a vacuum situation and you pucker the top of the tank in. So it is very important to keep the pressure relief valves on top of the reactor maintained properly, because if you do not, and you have a issue of pressurization or vacuum essentially breaking the top of your reactor roof, that is not fixed without taking the entire system down, emptying it, getting the tank guy out there, etc. So you're talking about weeks of downtime. So that's very important to keep maintained.
Back to the flame arresters, we have another question. What products or how would you recommend cleaning those banks out? Jill?
Most of the guys that I've worked with just use, most of the time they're not very dirty, and just a regular garden hose is enough to clean them out. If it's scaling, it's a little more dicey. You can use a pressure washer, and I'd have to check with the manufacturer on if it's scale, what type of acid you might want to use to get it off, because you could just soak it in an acid, but I'm not sure what type of acid to use. You'd have to check with the actual manufacturer. Thank you.
Yeah, so most of the time that arrestor buildup is just dried crud and other stuff over time. So a hose, you can actually get a little bit of pressure in it, cleans off everything. And if you have scale buildup, the biggest thing is going to find out what that scale buildup is, and then figure out what acid will actually dissolve it, and make sure that acid is compatible with the flame arrestor itself. At a certain point, if you have a whole lot of scale buildup, it might be just more cost effective to buy a new bank and just throw that other one out.
Okay, we have another question about instrumentation. How many times per year should the pH probes in a system be calibrated? Greg?
No, let Jill answer that one. She loves pH probe calibration.
Okay, I'm the pH witch, I guess. You should be checking the pH in the line where the inline pH probe is. You should take a sample of the water from that line every day and take it into the lab and measure it there and compare it to what the inline pH is reading. Okay? If that reading is more than like 0.2 to 0.3 units different, then you need to take the inline probe out and clean it first, and then after you clean it, put it in buffer 7. If it reads buffer 7, put it back in line. If it doesn't read buffer 7, then recalibrate it with buffer solution and put it back in line. Every plant is different, and every pH probe in the different locations is different. So the influent pH probe may only need to be checked, may only need to be cleaned once a month or something, but the effluent may need to be done once a week. Everybody's different. That's why you check it every day. And the really important ones are where you're doing your pH control and in the reactor effluent. Those are the most important ones to really, really keep an eye on. Does that answer their question?
I think so, Jill, and feel free to ask a follow-up question. We still have some time available. We have a question, and it's about lights. Should lights on top of the reactors be explosion-proof? Greg.
So the answer to that is yes, they should be. On top of the reactor is typically a Class 1 Division 1 area because you have pressure relief valves up there. Those pressure relief valves do pop once in a while. They will weep a little bit or leak a tiny bit, especially the older that they get, especially depending on how close those pressure relief valves are set to the actual operating pressure of the reactor. But when we classify our systems, currently we do classify the area on the roofs of the reactors as Class 1 Division 1 explosion-proof. So not only explosion-proof light should you have up there, you also need explosion-proof wiring and conduit. That's the key. It's no sense having explosion-proof light if you're going to run regular wiring to it. So that is something that you should have your electrician make sure he does both of that.
And we have another question. I'll let Greg read it and answer it.
What is the best way to clear out a crystallized caustic line due to cold weather? Caustic freezes, what does it freeze at, Joe? 65 Fahrenheit?
50% freezes at 55 Fahrenheit.
55 Fahrenheit. So your caustic lines, unless you are, have a reactor and you're listening from maybe Miami or Key West, which I don't think we have any reactors down that far. Your caustic line should be heat trace and insulated if it is outside, because obviously 55 Fahrenheit you're going to get all the time. But if you do end up having issues with you're not pumping as much as you think you should, or you see sort of some crystals forming around, Jill, I haven't unplugged a whole lot of caustic lines in my life. How does that typically work?
If it's still pumping and not totally blocked, sometimes running just water through it will clear it. If it's really clogged and you can't push anything through it, I have to say, unfortunately, the best way to do it is to cut it and replace it. I know that's not what they wanted to hear, but that's often the fastest and least expensive way to do it.
And also remember, if you work on a caustic line, caustic is like acid in that it will burn you. So that is something when you're working on a caustic line, you should make sure you have your proper PPE from a safety standpoint. You're talking chemical gloves, you're talking a face shield, a chemical apron. Make sure the pump is turned off. I've seen people take off, loosen up a caustic line, forget the pump is on, and then it squirts on them. And it burns. Another thing too is if you think you have a leak in a caustic line and it's heat traced and insulated, and you start taking the heat trace and insulation off. I've seen somebody do that with their bare hands once, and they took the heat trace and insulation off, and it was soaked in caustic, and they didn't really think about it, and then all of a sudden their hands start burning. So when you're working on a caustic line, PPE, people don't think caustic is like acid, but it can be just as bad.
And one last question is, if a system requires service or maintenance beyond what the operator should do, what would be their preferred method in getting in contact with Biothane and Veolia Water Technologies?
So if you have maintenance questions, I say specifically if you're going to do some reactor maintenance or you're going to do an inspection, as some people might have older reactors that are coming up on 15, 20, 25 years, you should be thinking about a downtime reactor inspection if possible. We can help you plan that inspection. We can help you do, we definitely recommend that one of our engineers comes out because unless you were there when the plant got put in, you've probably never seen a settler, so you don't know exactly what it should look like. So we have people that can come out, that can, inspect what you have. Sometimes we actually even recommend that you order some replacement parts in advance because when you take your system down, you're going to not have time to say, oh, I need this bolt or I need to replace this weir, and then go order it online and have it come. This is not Amazon Prime where you can get overnight shipping of these parts. Sometimes these parts take weeks to get, and you don't want to have your system down for weeks. So when you're planning an outage, definitely get us involved. If you're just looking to get some biogas maintenance done, we recommend actually contacting the vendor. A lot of you guys have Veric equipment. They have some good techs that will come out and show you how to do everything. I suggest you have your whole maintenance staff there to see how it works, maybe even take some photos or take some movies to understand how to do it. If you're looking at potentially cleaning out your feed piping, sometimes we can just work through that with a phone call just to review things. We can send a technician out on site for the day that you do it, just so you have somebody there that can help you work through those things. So the best thing is to contact Jill Jordan. Her number's up on the thing, webinar there, or email her, and then she will figure out who the best person in her office is to help you out. But we do have people that go out to the site to help you do inspections or help you do clean outs, and also talk you through potentially if you have issues. So we do have a service department that can help.
Great. Thank you so much, Greg. Thank you so much, Jill. I'd also like to thank the client who's hosting Jill at this time on site as she's working from their facility. And also I'd like to thank everyone who has participated and joined these webinars throughout the year. This is our first year in performing these webinars, and we look forward to hearing your feedback and continuing this program. We find that it's valuable, and the feedback that we receive from everyone is very positive. So we'd like to continue to maintain these continuing education events. So with that, this concludes our webinar. I would like to thank everyone and wish everyone a happy Thanksgiving next week. Thanks, everyone. Bye-bye.